Does an AI agent really re-explain its entire identity, every tool, and every rule on every single message you send it? If it did, that would be slow and expensive. The real answer is more interesting. Most of the prompt never gets rebuilt at all. Today we open the file that decides exactly what gets rebuilt and what gets reused. Welcome back to the Hermes Agent Deep Dive. Part 1 mapped the repository. Part 2 opened the loop that drives a single turn. This time we look at something that sits upstream of all of it, the system prompt itself, and the exact function that assembles it before the model ever sees a message. Once again, every file and line number on screen comes straight from the pinned v2026-7 release of NousResearch's Hermes Agent, so you can open the same source and check it yourself. By the end of this part, 5 things should click. Why the system prompt isn't one long string, but 3 separate tiers built and joined in a specific order. What actually lives in each of those tiers, and why the split isn't arbitrary. How the agent's identity block falls back to a hard-coded default the moment there's no SOUL.md file to load. How project context files like AGENTS.md or CLAUDE.md get discovered on disk, and why the code deliberately only lets one of them win instead of stacking all of them. And finally, why the entire assembled prompt gets cached and reused across a whole session, only rebuilt when context compression forces the issue. This is the part of an agent framework that decides how expensive and how consistent every single turn actually is. Strip away every helper function, and the whole file does 5 things. Build the stable tier: identity, tool guidance, skills prompt, environment, and platform hints, none of which should change mid-session. Build the context tier: whatever system message the caller passed in, plus at most one project context file discovered on disk. Build the volatile tier: the memory snapshot, the user profile, and a timestamp line, all of which are expected to shift. Join all 3 with a blank line between them into one string, and cache that string on the agent object, reusing it turn after turn until something specifically context compression forces a rebuild. The names aren't decorative. Stable really means stable, and volatile really means rebuilt every single time. A few things will help before we dig in. Python 3, 10 or newer, and your own clone of Hermes Agent, checked out at tag v2026-7 to match every line number we cite. Have both agent/system_prompt.py and agent/prompt_builder.py open side by side, because the interesting logic is split across the 2 of them. It also helps to have a rough sense of what prompt or prefix caching is, and why providers charge less for tokens they've already seen before, because that's the entire reason this file is built the way it is. Watching part 2 on the agent loop first will help you place this in context, but it isn't required to follow along. Start with the docstring at the very top of the file, because it tells you everything before you read a single line of real code. The system prompt is built once per session and reused across every turn, and only context compression triggers a rebuild that's stated as the whole point, to keep the upstream prefix cache warm. Then it names the 3 tiers directly. Stable holds identity and tool guidance. Context holds the caller's system message plus discovered project files, and volatile holds memory, the user profile, and a timestamp. Every function below this comment exists to fill in exactly those 3 buckets. This is build system prompt parts at line 113, the function that actually does the assembly. Skip past the setup, and the very first thing it does is decide the agent's identity. It tries to load SOUL.md, a persona file, unless the caller explicitly asks to skip context files entirely. If that load succeeds, that content becomes the identity. But if there's no SOUL file at all, which is the normal case for most deployments, the code falls back to a hard-coded constant called default agent identity. No exception, no missing identity, just a clean fallback. Here's that fallback in full, defined in prompt_builder.py. It's short on purpose. Hermes Agent, built by NousResearch, helpful, knowledgeable, direct, and willing to admit uncertainty rather than bluff. Notice the very last line be targeted and efficient in your exploration and investigations. That single sentence is a deliberate steer against a common failure mode in coding agents, wandering through a codebase reading far more than necessary before doing the actual work. Even the fallback identity, the one every deployment without a custom persona gets, is quietly opinionated about how the agent should behave. Now the context tier. It starts empty, then two things get added to it in order. First, whatever system message the caller passed in directly, this is how a gateway integration or a script can inject its own instructions for a specific run. Second, unless context files were explicitly skipped, it calls build_context_files_prompt, passing along the resolved working directory and whether the identity slot already consumed the SOUL file, so it doesn't get duplicated. Whatever that call returns, if anything, gets appended to. This tier is the one place caller intent and project configuration actually meet. Inside build_context_files_prompt is a decision worth pausing on. It checks for 4 different kinds of project context file in a strict priority order. Hermes.md first, then AGENTS.md, then CLAUDE.md, then cursor rules. And it chains all 4 calls with pythons or operator, which means the very first one that returns real content wins, and the other 3 are never even loaded. If your project has both an agents file and a Claude file, only one of them ever reaches the model. That's not a bug to work around. It's an explicit design choice to avoid stacking multiple, possibly contradictory, sets of project instructions. Whichever file wins still has to fit inside a size limit, and that limit isn't fixed. This function derives it from the model's own context window. Below a floor of 20,000 characters, the historical default, and above a hard ceiling, it computes a budget as a fraction of however many tokens the model can actually hold, converted to a rough character count. Give it a small local model, and you get the 20,000 character floor. Give it a model with a huge context window, and the cap scales up with it, letting a bigger agent's file through without truncation. If the model can tell the difference, the prompt building code should too. The volatile tier is the odd one out, and its name says why. If the agent has a memory store and memory is enabled, its current snapshot gets formatted and appended. Separately, if a user profile is enabled, that gets its own block. Notice these are 2 independent checks, so you can run with memory off and a user profile on, or the other way around. Then, regardless of any of that, a timestamp line gets appended unconditionally, built from the current date. Crucially, this line uses date-only precision, not minute level, specifically so the volatile tier, and the joined prompt around it, stays byte stable for an entire day instead of invalidating the prefix cache on every single turn. And this is where the 3 tiers actually meet. Build_system_prompt calls the function we just walked through, gets back a dictionary with stable, context, and volatile as separate strings, then joins exactly those 3, in exactly that order with a blank line between them. That's the entire assembly. What matters more than the code itself is the promise around it, stated directly in the comment, called once per session, cached on the agent object, and never rebuilt mid-session except after context compression. Every optimization in this file only pays off because that promise is kept. A few notes before you build on this pattern yourself. Pin the exact tag or commit your citing the same warning from part 2 applies here. This codebase moves fast and line numbers drift. Don't try to get more control by stacking an agents file and a Claude file and a cursor rules file in the same project hoping they'll combine only one wins. By design. So put everything that matters in whichever one your tooling actually reads. Respect the dynamic context file cap rather than hard-coding a bigger number in your own fork. It's scaled to the model on purpose. And if you spot that timestamp only carrying a date, not a time, that's not an oversight. It's what keeps the prefix cache warm across an entire day of turns. One practical habit if you maintain a project context file of your own. Schedule a simple daily check on its size. This cron line runs every morning and logs the byte count of your agent's file to a running log you can watch over time. It won't stop the dynamic cap from truncating an oversized file, but it tells you well before your users notice that half your instructions quietly stopped reaching the model, instead of discovering it while debugging a confusing agent response weeks later. Let's pull it together. The system prompt isn't one blob. It's 3 tiers: stable, context, and volatile, built by build_system_prompt_parts, and joined by build_system_prompt. Identity always resolves to something: the SOUL file if it exists, the hard-coded default agent identity if it doesn't. Project context follows a strict priority order, so exactly one file, never more, reaches the model. And every piece of this, the caching promise most of all, exists to keep the prefix cache warm, because rebuilding all of this from scratch on every single turn would make every conversation slower and more expensive than it needs to be. That's prompt assembly, the part of Hermes Agent that decides what the model sees before it calls a single tool, straight from the pinned source with every line cited. Part 4 goes one layer deeper still, into what happens when a session gets too long for that cached prompt to keep working. Context compressor, prompt caching, and the breakdown logic that decides what gets summarized away. If you want the rest of this series as it publishes, subscribe now. Thanks for watching, and I'll see you in part 4.